Hello, and welcome to our set of videos for Chapter 18 on the fundamentals of spectrophotometry. So this is the beginning of our final unit for our class. So we've looked at doing volumetric measurements, titrations of various kinds, acid-base titrations, precipitation titrations, EDTA titrations. We've also looked at using electrochemistry to do analytical measurements. And this last unit, we're going to be looking at using light, properties of light to do analytical measurements. And we've done this work in the lab, but now we're going to look more at the fundamental ideas behind it. In particular, in Chapter 18 is sort of lays the foundation for the ideas behind spectrophotometry, looking at the properties of light and a brief introduction to how spectrophotometers work. Then we're going to skip Chapter 19, which is some specific applications. We may get to a little bit of it in class. Then Chapter 20, we're going to be looking at actually how you build a spectrophotometer, what are the different parts that go into it, and how you actually construct it, which I think is a really interesting topic to look at. And then in Chapter 21, we're going to look at one particular application of spectrophotometry that's very commonly used, and that is atomic absorption spectroscopy. And so that sort of lays out what's going to be happening for the next, till the end of the semester. So, Chapter 18, Fundamentals of Spectrophotometry. So this is one of my favorite topics because this is directly related to the research I do. So I do infrared spectroscopy, so IR, or infrared spectroscopy, which is one type of spectrophotometry. And this specifically measures molecular vibrations, is what I look at with my research. But spectrophotometry is a widely used technique that's done with lots of different applications. So my particular application with my research is atmospheric chemistry. So I'm interested in studying molecules that exist in the atmosphere with spectrophotometry to measure their concentration levels and other properties. But there are many other applications. One that I find particularly fun is astrochemistry. And so this is using the properties of light, we can measure molecules that exist out in space and understand their chemistry and how they react with each other. Other areas that IR, or just spectroscopy, not specifically IR, shows up, process monitoring. The characteristics of spectrophotometry are really useful for this because you can do measurements without using up your sample. And so if you're monitoring a process as it's happening, you don't have to take something out of it. You can possibly just take measurements as it's happening. Other things can include biological assays. One thing that's commonly used with this is fluorescent proteins. So you can use the ideas of spectrophotometry to measure concentrations of proteins by attaching fluorescent tags to them. And I'll just put others here. There's lots of other potential applications of spectrophotometry, and more are being invented all the time. And so it's a very versatile technique. As with any technique, there are always pros and cons, as we've talked about with everything else. Right? You can't use spectrophotometry for absolutely everything. There's some things it's not going to work very well for, but there are a lot of things it does work really well for. And just want to briefly mention some of the key advantages right up front. For spectrophotometry, and we'll see this as we work through it, your sample is not consumed. So when you do something like a titration, the reaction has to happen. You have to use up your sample. Spectrophotometry is similar to electrochemical measurements in that you don't have to use up your sample to take the measurement. You can take the measurement, and then in theory, after you take the measurement, you could use your sample for something else. One other key advantage, because we're using light, you can get light to places that you can't necessarily get a sensor or something like that. And so remote monitoring is a possibility. It can be tricky to actually set it up, but it is possible. And the fundamental way that measurements are made involves light being absorbed by molecules. And almost all molecules or atoms absorb light in some region of the spectrum. And so you can use this for this is useful for a wide variety of chemical species. So you're not limited, for example, in an acid-base titration, it works great for acids and bases, but you can't generalize that to any molecule you want to measure. Same thing with electrochemical measurements. There has to be some redox reaction that you can monitor. Though ion selective electrodes make that, you can expand that a lot more. Same thing with spectrophotometry. As long as there's light that's either absorbed or emitted by a particular molecule, and you can, separate that from absorption and emission of other things, you can do spectrophotometry of that molecule. So that's a little introduction. In the next video, we'll start looking at some of the properties of light and how that's an important thing to understand when we're using light to make these measurements.